All right. Good afternoon, everyone, and welcome to the RITIS User Group meeting, March 5th, 2026. We thank you for taking the time to join us. Just a few reminders. We use Zoom webinar, so you can join on your computer or phone for audio. We are recording this meeting. If you have any questions about the meeting, please contact me directly. My email address is there. You can send me an email. And then we also have the Q&A box that you can put questions in, and we can answer those questions for you. Just a little visual to show you how to do that. If you're new to Zoom or don't use it all too often, just click on the Q&A and the box will pop up to enter the question. You can also use the raise hand feature if that's easier for you, and then we can unmute you or you can unmute yourself to ask the question. Just an upcoming reminder, we do these meetings quarterly, so our next one that we have on the books is June 4th at 1:30 p.m. So that invite will be coming out sometime in April, so keep an eye out for that. And if there's any questions on invitations for the meeting, please reach out to me, send me an email, and we will coordinate that to ensure that you get the future invites. And now I'd like to turn it over to our RITIS User Group Co-Chair, Jesse Burke from the Capital Programs Department at Delaware Valley Regional Planning Council, and he's the Associate Director. Jesse?
Thanks, Nicole. Hey, everybody. Thanks for joining us today. As always, great to see so many people joining in, over 100 different folks joining. So it's great to see folks from all around the country. If you go to the next slide, Nicole, just go over the agenda for today. So we've already taken care of some of the housekeeping. Next, we'll just do a few poll questions, help us understand, if folks have been joining these meetings before, or if this is your first one. So we'll see those in just a minute. Then we'll get into what's new and coming soon, some new features from Michael Pack, Joe Strube, and Charles Latimer and Greg Jordan, the Cat Lab team. We'll go into some PM3 reporting updates, and then we'll have our agency spotlight presentations, several different presentations, latest use cases of some of the tools. And finally, as always, we'll wrap up with some user feedback. And so, as Nicole mentioned, there's several different ways to comment or contribute. So we look forward to your feedback as always. So first we have these poll questions open here. Go ahead and fill those out. Um, and we can introduce the speakers, I guess, if you want to go back to that one. So we have a whole bunch of different speakers today. Lots of different folks. Thanks to everyone who's contributing here. Michael Pack, as always, is director of the Cat Lab at the University of Maryland, where he works to make transportation data more easily accessible and usable by ops planners and researchers. Michael previously worked at University of Virginia and Oak Ridge National Lab. Also, we have Greg Jordan, Joe Strube, and Charles Latimer, all from the Cat Lab. In the interest of time, I'm going to skim past some of the bios so we can get to the meat here today. Just want to also introduce William Morgan, who's from the Georgia Department of Transportation. William is a transportation engineer there and the Intelligent Transportation Systems Group at the Transportation Management Center in Atlanta. His primary focus is trying to make the ramp meters work in Georgia, and he's going to tell us a little bit about that today. He earned his bachelor's in civil engineering from Purdue University in 2021, and his master's in civil engineering from Georgia Tech in 2023. He's been at GDOT for the last couple of years. And I think we'll have the other folks introduce themselves when they get to their presentations. So hopefully at this point, folks have had a chance to respond to the different poll questions that we have here, letting us know how often you attend, how you use the different tools, and kind of what is the audience that you tend to use these tools for. I think with that, we can move forward into the first presentation here. So I'll hand it over to Michael Pack and the Cat Lab team to go over some of the latest updates.
Thanks, Jesse. We've got quite a lot to go over today. Um, and if we could go to the next slide, please. So just some quick updates on the RITIS Enhancement Group. So the RITIS Enhancement Group is the group of it's different states that look over all of the potential enhancements that have been offered up by users or proposed by us. They meet once a quarter. Bob Fry with MassDOT leads this effort. And the states contribute funding that is then used to pay for new features and enhancements in the system. The enhancement group just finished voting on 25 potential enhancements for consideration this coming year. And we are going to be meeting again on March 12th to review the results of that voting and make plans for how we're going to proceed. So there will be exciting new news to report come the next time we get together for the RITIS user group and what we're going to focus on next year. Meanwhile, there's other states that are just paying for enhancements on their own outside of this group, but it's a cool group. And if you're interested in joining this, please reach out to Bob Fry at MassDOT, and he can help you get access to the invites and everything. And we'll post Bob's email address here in just a few minutes. Next slide. With that, I'm going to hand it over to Joe Strube here in the Cat Lab, who's going to talk about the big project that we worked on last year with the RITIS Enhancement Group that is now deployed and available. It's the Work Zone Performance Report. Have at it, Joe.
Thanks so much, Michael. Yes, the Work Zone Performance Report, where you're going to be able to perform simple, repeatable Work Zone Performance reports and get those as PDF outputs. And if we could go to the next slide, we have some of our key features. It's going to be launchable anywhere in RITIS where there is agency Work Zone data already integrated. You're going to be able to launch them and work with them manually as well. But one of those key features is that integration of agency work zone data. You have configurable performance goals. You have work zone analysis. You can do it just for the work zone, or you can include upstream and downstream segments. You can overlay weather and traffic incident data. There's counts and information where those types of incidents, those things may have influenced performance metrics. And then you have your output is a dynamic PDF report. It's ready for export and distribution. And I'm going to go ahead and share my screen and show you some of that output. See, somebody can confirm you're able to see my screen. We
Yes.
should have wonderful. Thank you so much. This is page one of that PDF report. It is a summary. The first page is a summary of the report, a summary of the congestion metrics. You have a high-level view of what that work zone is. You have a configurable roadway diagram, configurable goals, success indicators for congestion metrics, speed metrics, and delay metrics. I'm going to scroll down to page two. That PDF report, you're going to dive into details for those performance metrics. So congestion is on page two. You have that road diagram as well, indicating when the work zone was active, and congestion length and duration is visualized during that time where that work zone is active. Scrolling down to page three for speed metrics, you might be familiar with the congestion scan. This is a visualization of a congestion scan, highlighting the work zone location where congestion is occurring or where the speed is happening on that congestion scan in relation to the work zone active hours. And again, those summary panels in terms of speed through the work zone, average speed approaching the work zone, max and min speeds, and then travel time through the work zone as well. Details for delay metrics starts on page four. The first delay metrics details page is going to give you a visualization of vehicle hours of delay on top of that road diagram. So you have a visualization of those hours of delay. Again, on that road diagram. Down to page five, you have if you're familiar with that user delay cost tool, you have two tables here for user delay cost tools. It's going to give you vehicle hours of delay, and it is going to give user delay cost by day of week and hour of day. Again, we're highlighting one of those, we're highlighting the work zone hours, the active hours for work zone. And then in the summary panel, you can see there's a significant amount of delay happening outside of work zone hours. That summary panel is only calculating what's happening during the work zone. So how do we get to these results? I'm going to jump over to our tool. Again, it is launchable from anywhere in RITIS where there's integrated work zone information. If you're familiar with the incident list, you can have this indicator here, this icon. You could launch a report from here. For the work zone performance monitoring application, you're able to launch it from here for that individual work zone profile. Today, we're going to launch it from the Region Explorer. We're going to be looking at a work zone that was active in August of 2025. So I'm going to go ahead and launch that report. This is on I-95 between exit 118 and 126. And this is, again, so that work zone location's already brought in to the PDA query form, which you might be familiar with. I am going to indicate, or I'm going to add upstream and downstream segments. So I'm going to go search in Virginia for I-95. I'm going to select intersections. I'm going to select partial. And then I'm going to 606. And I'm going to go BA-3. Whoops, my apologies. Scrolling. My apologies. Gonna jump over and select from the map, scrolling in here. And I'll add my second location. Added my route. I can select my dates. This is in 2025. There was a milling event occurring, milling and paving event occurring in August of 2025. I'm going to select the 7-day period that I'd like to run my report. It was only active Sunday through Thursday in the overnight hours from 12 a.m. to 4:30, 9 a.m. to 4:30 a.m. So I'm going to add my hours. And then I am going to add a comparison time period from 2024. And that same first week of August, and I'm just going to launch my event. Now I'm into the tool. I have that PDF. I'm going to configure my goals. I'm going to set 1 hour, 1 mile, and 10 minutes for my congestion metrics. I'm going to set my goal for speed as 55 miles an hour through, and my delay metrics set because I've checked the baseline 500 hours of delay. I'm going to configure my work zone location. I have that highlighted. And now my report is already launched and I can scroll through everything we've walked through in terms that the report is complete. And to get that PDF report, I'm going to simply export as PDF and I'm going to launch that. If you'd like to know anything more, we can jump over to that next slide, which is slide 23 or 24, and we have documentation ready for you to walk you through and you can produce those reports on your own. Thank you so much.
Thank you, Joe. You can stop sharing your screen and I'll start to share mine here. All right, can you see a big map now? Anybody?
Yes, we do see it.
Awesome. Okay. So I'll go over a few more updates that have been made recently, or at least since the last time we met. The first is a new real-time map. We're calling it the beta map. Has been deployed. Everyone who has a RITIS account should be able to see this now. You go to transportation system status, you hit traffic map. This map has both a 2D and a 3D view that you can click on and go and explore the world. The layer list should be pretty much the same as what you're used to. You may have to go and configure some of your settings a little bit differently to turn on and off the layers that you care about. It should be more performant than what you've seen in the past, especially with drawing the pro base speed layers and some of the other more dynamic layers. So check that out and give us any feedback that you have on that. Some other stuff that we've updated for the probe speed layer pop-ups. If you double click on a segment, it pops up and it tells you what the current speed is, plus what the speed has been like for the past X number of hours. These graphs are now dynamic, where you can go and you can interact with them and you can zoom in on different time periods to get a better sense of how the speeds have changed. It's particularly useful if you had a crash or something where you want to look at the change in speed. The next thing we've done is we've updated the weigh in motion or the virtual weigh station mapping in analytics. This is another layer that's available on the map. It'll show you where your weigh stations are located, and you can click on them, and you can either open up live station data if that's available, or you can go to the analytics page. For the live data, you essentially go in and you can either select from the map, or you can select a station from the list, and then it will start to load in the vehicles and the weigh data. If the screen turns red, that means the vehicle is overweight or speeding or unbalanced, something like that. But you see other diagrams that explain the axle space and the axle weighting of all the vehicles. That's the live data. For the archived side, again, you can either click on an item and go to it, or you can click on the list, and you can select a date range that you're interested in. And you can also go in and turn on the different types of weigh station metrics that you want to analyze. So maybe you just want to look at certain vehicle classes, or maybe you just want to look at certain lanes or certain weights. You can enter in all of those different things. And then when you hit submit or search, that is, it'll take a few seconds and it'll go out and it'll bring back all the statistics by hour of day and day of the week. And there's all sorts of other graphs that you can bring up to take a look at different violations and other metrics by time of day, day of week, what have you. Yeah, you can export all of this data to a CSV file for analyzing in Excel as well. The next thing we've done is for media attachments. So some agencies, if they have responders out in the field, they will take pictures of things. Maybe it's what's happening at the crash site or the cleanup or disabled vehicles, and they will then upload those into RITIS for archival. Now in the incident pop-ups, you can get access to those images more easily. You can still get access to them in the event query tool, the historic analytics. But this makes it a little bit easier to see them live as things are going down. For those of you who are purchasing private sector data for something called dangerous slowdowns, the dangerous slowdown data is available in the live RITIS website, or you can go in and you can do historic queries to go in and pull up information about where these dangerous slowdowns were occurring during a particular date range or time of day. So again, it kind of looks like the weigh station analytics, but you're able to drop down and look at dangerous slowdowns by hour of day, day of week, so on and so forth. You can also map the locations of those dangerous slowdowns and zoom in and get more information. You might have particular hot spots that you need to look at for some safety countermeasures or something like that. So that's now all available as well. The next thing I want to mention is a work in progress. So we're pleased to report that we've just been awarded a fairly significant Federal Motor Carrier Safety Administration grant. It's a high priority. It's a grant titled High Priority for Commercial Motor Vehicles. Our project is called National Compass, which stands for National Comprehensive Analytics Safety Suite. What it's allowing us to do is providing the funding for us to go out and partner with several different commercial motor vehicle data suppliers and pull in their data and create a safety analytics suite within the RITIS platform that will show things like truck parking in unsafe locations, truck safety events, so harsh braking, hard cornering, other acceleration events, that sort of stuff. So we're going to create several different dashboards. They're going to allow states to go in and look at commercial motor vehicle safety throughout the entire country. But we're going to pay special attention to doing some studies for how this safety data can be used to understand safety in work zones and also safety in rural areas. So we are a solid year away from being able to produce any results on this, maybe longer, but this is new funding that's coming in from the feds that are going to allow this to be built out. We're excited about it. Next, we have a few updates on signal-related analytics. Got some new features and other updates, and Charles Latimer is going to be updating on this. Charles, are you there?
I am here. All right, thank you, Michael. So we've been busy on the signal side of the house and wanted to take a few minutes to bring you up to speed on some of our recent enhancements and some exciting new features that we have on the horizon. Next slide, please. So during our last user group call, I went through a handful of use cases for using the intersection analysis tool to identify potential issues with timing or detection. And this involved creating some customizing your tables and filters, within the tool there, and then saving those table settings as a preset. So at the time, I promised that we had some written guidelines were coming soon, and I'm happy to announce that these will be available this month on our RITIS template site. You can see the link there, learn.ritis.org/reports. So our goal is to develop this into a full template like we did for the other types of reports. We're waiting on a couple of new signals tools to come online first because we want to integrate that into the workflow process to feature those. But we want to make sure that the information on the presets got into your hands now. So next slide, please. So for those of you who couldn't join us at the last meeting, or maybe just a refresher for those who were there, this is a quick look on how to use those presets that I'm talking about. So when you open up your intersection analysis report, you'll see kind of at the top of the table there, there's a new drop down that's for presets. You can see that there, what it looks like when it's expanded in that orange box there. Next slide, please. So to build the preset, it's a three-step process. So the first thing you'll do is you'll apply any filters you want to your table, and then you can choose the columns you want to see, either add or hide those. And once things are set up the way you like, there's a save icon, little disk icon there next to number 3. You click that, and then you can add a name and save your preset. So then after you do that, it'll show up in the drop-down list, and you can then pick that at any time in the future to apply to your table. Next slide. So we've also made some major performance improvements to the platform. So our data provider recently implemented a new API and a new data architecture on their side that has really improved the efficiency of generating reports. And we switched over to that at the beginning of February. So you may have noticed some significant improvements. Reports that used to take hours or many minutes to complete should now come back within 1 to 2 minutes or even seconds. So check things out. If you haven't run any signals reports recently, you should notice a huge improvement. Next slide. So moving on to our coming soon category, the next tool that is on the way is called Intersection Trend Charts. We're working on this now. One of the biggest asks that we've gotten from customers is for better ways to visualize the results for before and after studies or to see how the performance changes over time. So that's the purpose of the trend charts tool. You'll be able to pick a range of days, weeks, or months, and then see line charts and bar charts of how things change. So we plan to deploy this tool by the end of next month, April, hopefully before, but fingers crossed, but should be out definitely by the end of next month. And this will be available to all Signal Analytics users kind of as a new tool on the landing page. Next slide. The following tool in the pipeline will be called Intersection Performance Charts. And this is going to let you look at daily patterns of performance. So this will be good for identifying like where a timing plan might need to be tweaked or spotting some unusual delays, maybe in the middle of the night or during off-peak conditions. So we don't have a specific date for the deploy for this one yet, but it should be out before the end of the year. Next slide. And finally, I want to talk about a brand new thing that we are offering for our full RITIS customers. So ATSPM version 5. This is something we've been wanting to get involved with for some time now, and we're finally glad to be able to announce this. So in addition to the probe-based signal performance measures that we were talking about in the current platform, we're now offering cloud hosting of ATSPM for agencies in full RITIS states. So this cloud-hosted ATSPM includes version 5 of the UDOT software, which is the newest version of their software, along with data storage for high-resolution controller files. We know one of the main barriers to entry for agencies is that are considering ATSPM is figuring out how to size your server, install and maintain the software, and figure out how to kind of store your log files there. So we can take care of this for you as long as you put your files and configuration in a central location that we can pull them from. So we do have a live demo running now for one of our states, and we're ready to start having discussions with others who might be interested in taking advantage of this. This would be a good opportunity if you're on the fence with ATSPM, or maybe you have version 4.3 deployed and you want to upgrade to version 5. This would be kind of a low-risk way to do that. The new 5.0 architecture should also make it easier for us to customize things and come up with new visualizations on our end. So let us know if that's something you'd be interested in, and we could kind of have some discussions about that as well. So next slide. So these are just a couple examples of what version 5 looks like. So this is a basically the Purdue coordination diagram. Next slide. We have some of the time-space diagrams along a user-defined corridor. You can kind of see that. Next slide. And we've also implemented the link pivot table for that same corridor. So that's where you can kind of come up with an experiment and kind of tweak your timing for that corridor. So if you'd like more information, feel free to reach out to us and our support, and we'd be happy to talk further. So with that, Michael, I'll hand things back over to you.
All right, we're actually going to hand it over to Greg Jordan now to give us some trip analytics updates. Greg?
Thank you, Michael, and thank you, Charles. Okay, trip analytics is taking databases of real-world trips, where they started, the pathway they took, and where they ended. And the question is, how can we glean information from these? We've done some major upgrade work. Essentially, the way we find trips is we put a polygon on the map and we say, if a pathway of a trip went through this polygon, pull it out. And then we get similar trips, like if that could be a downtown area, we say any trip that ended up inside this area from 7 to 9 in the morning, that'll tell a story about how commuters got to downtown and those kind of insights. So we're improving the way that you can put polygons on the map. So next slide, please. Today, you can put one polygon on the map and you get to choose whether you want trips that started inside, ended inside, or outside, and so on. Lots of flexibility to focus whether you want arrivals or departures or cut-throughs or something like that. That's single mode. The next mode we also have today, it's from to, where you have two of them. And your started inside or started outside options apply to one polygon. And then what polygon did it go to? And then you can also use your checkboxes for pass-through. So that's what's there today. Now we're adding two more modes. Next one, please. You're going to put as many polygons on the map as you want, and you can say find any trip that touched any one of these. That's called any mode, and there's no limit to how many. Next, enter, please. Or you can have all mode. It's kind of like skiers going down through gates. If you want to define a very complicated route, you just put a gate over each one, and you find only the trips that went through those gates. So those are both in the works. And oh, by the way, each of these two new modes, go ahead, hit enter, please. Each of those can be inserted in between a from and a to so that you can get directionality, or I'll show an example of how that might be handy. Next slide, please. We're improving the interface. This is what it's going to look like. At the top left, you see single mode, from, to, any, or all. So we've hit the tab for a from to, and you've got your from polygon in that black box. That's where you load up your first from polygon. And then you have your through polygons underneath that. Those are your middle filters. And then you also load up your to, and you can have as many black boxes as you want. For example, hit enter, please, Michael. This is what it looks like. On the top left, you have 3 bars. Those are the from, and we're using any logic. Go to the map. The bottom right of the map has 3 polygons. Those are your 3 froms. Now jump to the bottom where it says to, T-O. There's 1 polygon for to, that black bar, and that's the giant area in the middle, top middle of the map. That's your to, but there's a river in between, and what we want to do is we only want trips that used any one of those bridges. So we have 5 bridge filters. They're gates that go across them, and notice you have any or all. Well, in this case, we've checked any, and so we're going to find trips that went from those 3 through any one of those bridges to the 2. So it's a way to pick exactly the trips you want and none that you don't want. We've also added a holding area at the bottom because you can actually have a lot of flexibility to create a polygon and then park it down in the holding area and save it for later. And you can literally drag and drop them and move them around to get the combination that you want to. So you have total flexibility. Next slide, please. The other thing I want to mention, we have a current beta testing group looking at our new truck parking analytical dashboard. I'm not going to go into the detail here, but we've got about 25 people working with this now. We're about to add the month of March, but we're having our beta testers go out to the field and document whatever it is they want to document so that at the end of the month, they can get the data back and we can have evidence and documentation about, how well is it finding what you see in the field. That test is going on now. I invite anybody to send either me an email or through our support team. If you're interested in truck parking and want to be part of this testing, let me know. And Michael, that's all I have for this part.
All right, just a couple of more things before we get to our spotlight presentation. The next is real-time vehicle movements. We now have real-time vehicle movements that can be visualized on the beta map. We're currently only testing this in Maryland, DC, Northern Virginia, and Florida. But if anyone wants to take a look at it and see what it looks like, you can essentially see live moving vehicles on the roadways. It's particularly useful for real-time crash detour analysis. So this is a crash that happened in Florida on I-95. The crash blocked all the northbound lanes. So you can see traffic's only flowing southbound on this. And then down here, you can see all the queue building up and people trying to detour and get on this parallel road going up north. And then they're getting bottlenecked again as they're trying to turn left and get back on I-95 going north. There's a lot of interesting things I think are going to come out of this new data set. And let us know if you want to experiment with it and see what it looks like. And that's it for our updates this quarter. Again, if you have any questions or want to learn more about this, you can reach out to support, or you can give me a call or shoot me an email. We're happy to help you out. Greg, you're back. If you give us a quick update on the PM3 reporting updates.
Right. This is about 40 out of the 50 states are using this tool to do the reporting. I'll just give you a quick rundown. This is what the icon is. When you hit the MAP 21 rule, you see this red box at the top, and right in the middle of that red box is the word here underlined. That is the link to open up our update bulletin board. And the bulletin board basically tells you everything you need to know in order to comply with the regulation. Hit enter, please. Next. Here are the key dates coming up. In order to do excessive delay, we need any new segments that require posted speed limits. Agencies do that for us. We send a template out by email, and your people are working on it now, or maybe some people on this call. And we need those back by March 31st. And if we get them back by March 31st, our reports will be certified by us as ready to go by April 15th. That leaves you 2 months to have them uploaded by the required HPMS submission date of June 15th. Hit enter again, please, Michael. Remember that once you download it after April 15th, do a test submission to the FHWA portal. If there's any error, there should not be any error messages, but if there's any warning messages, send them into our support team, and we will tell you. Many of them don't need any action on your part, and some of them will. If anything needs action, we'll take care of it, but generally there's nothing there. But share it with us. And then the final version, make sure that it's after your certification date. Next slide, please. Now, there is a complication of this year. This is the end of a 4-year reporting period. And therefore, back in 2021, we set new targets. And then we have these 4 years, and now 2025, the data year 2025 that just ended, that is the year that we report whether or not we met our targets and what we're doing about it. So year 2025 has to look backwards to be compatible and comparable to the 4 years before that. But if we're looking forward, we now have a new 4-year reporting period that's starting, which is 26 to 29, but we also need to use 2025 to set the new targets. That means we have to restate 2025 according to the new definitions that came on board because of the census that took place in 2020, believe it or not. So we have this, so because of this, next slide, please. Every state got this very complicated technical looking notice from Federal Highways about all the things you have to do to solve this. Here's what you need to know. We're doing it for you. You don't have to worry about it. You don't have to think about it. All you have to do is send in the posted speed limits that we ask you, and we'll take care of the rest. Next slide, please. That's all I've got. And if you have any questions, feel free to reach out to me, or best yet, go through support@ritis.org. Thank you.
Thank you, Greg. Jesse.
All right. Thank you for all of those updates. As always, just a lot of incredible work going on. I see some folks put their email in the Q&A looking for more information. So with that, we'll move on to our first spotlight presentation, operations use cases for dash cam imagery. So I'll turn it over to Taryn Hutchinson.
Good afternoon. For us, this is a new data set that the CAD lab provided to us through this RITIS interface. RITIS is our common operating picture, and we're always looking at our center. We're always looking for information, data sets, visuals to help sort of tell the story, help with the coordinated response to a big event, or it could be a small event. And so we were trying to figure out, how do we work this into our workflow at our centers. Next slide. So one morning I was coming to work, and I passed, I saw some fencing that had fallen over on a median. And typically what we'll do is we'll call it in and get maybe have a shop go out and take a look at it, at least document it. And so when I got to the office, I wonder if this would show up in RITIS, and specifically a dash cam from a commercial truck picked this up. And so what you see there is I've taken this is the beta map, the new beta map. I've selected a segment of that roadway, which pops up, and it gives you the option of, do I want to see the speed graph or search for dash cams? And so what it does is I chose search for dash cams, and it goes back within the last hour and looks for anybody who's passed through that area and any dash cams that have picked up anything. And sure enough, you can see at what point, and what you're seeing is little dots are those recordings of that dash camera. And sure enough, it picked up what I saw, this missing panel or set of panels that had fallen into the roadway. And so then there was a quick call to the local center to say, hey, can you send maybe a safety service truck to go check this out? Next slide. So and sort of follow up to that was, well, we heard about this, damage to this guardrail a couple of days ago. We want to follow up on that. Was it dealt with? And so we do another search for the segment in that area, and sure enough, another dash cam pops up. We kind of scroll through them, and sure enough, it picks up. Looks like a shop unit might have gone by and put up barrels to warn people, hey, we've got damage to this guardrail. So again, another way we can kind of confirm, hey, looks like folks are addressing it. Next slide. So again, in RITIS, we look at the world through this sort of view. We see the map, we see the speed, the probe speed data. We have maybe CCTV from overhead, but we never get to see what's on the road. It's hard to pick up what do drivers see. So we did a little search for this incident, and then looked at the segment, and sure enough, there was a dash cam of a truck passing the scene. And you can actually see earlier on in the incident what he saw as he was passing. It was not a leaking tanker. It was just an oil leak from the cab that was draining to the side of the road. And actually, if you zoom it, in this case, we zoomed in, and you can actually see the path of this passing truck as it goes around the right of the disabled tanker. So yeah, a unique view which we can capture and then add to an event timeline. Next slide. And on a typical response, when we look at an incident, right, we look at the agency cameras maybe from overhead, but sometimes you don't have direct line of sight. If you're lucky, you might have a safety service truck that might roll up with a live dash cam that they can sort of move around, but the image isn't that great. And if you're really lucky, you might get maybe an agency PIO that'll tweet something out, show you a much clearer image. But then we thought, wait a minute, what if we can go back in time and see what happened with this? Where did this fire originate? So we did a quick search of this highway at that time when this event was. We knew when it was dispatched, so we did a search just before the dispatch time, and sure enough, there was a truck passing by, and as we get closer to the scene, you can actually see smoke starting in the engine compartment, and so this is the point of ignition. You can see the Penske truck starting to catch fire up on the right. So again, helps sort of provide context of what we're dealing with here. Next slide. This is another example of just kind of monitoring the public safety channels, media broadcasts, and we hear about a dirt spill. We know that the DOT is heading out to it. But we think they're not being dispatched to the right location, so we can kind of see the slowdowns and kind of figure out where folks this might start. We do a quick search for a dash cam in that area. Sure enough, we actually pick one up, and it actually shows exactly where the debris starts. So that's a quick call to the center. Hey, can you guys come in from this location? This is where you're going to be picking up the initial spill from. Next slide. Here's another one. We're monitoring a response, but there's no direct line of sight, so we're just relying on media broadcasts. We haven't seen an update in a while. Let's do a dash cam search, and sure enough, we can see they still have 2 lanes blocked on I-95. It's a single file getting to the left, back to the left. So we can relay that on back to the center. Yeah, the localities are still there. They're still blocking this crash with injuries, and we can kind of relay that back to the media and say, yeah, you're correct. It's still 2 lanes blocked, and so forth. So another visual to help tell the story. Right. Next slide. In this case, no cameras anywhere close to this incident. It's been there for a while. Media reporting is saying, oh, it's still all closed. The ramp's closed, and we're not entirely sure. So we do a quick scan. Sure enough. The ramp's actually partially open. through this dash cam. If you continue this, the truck actually passes the scene. They're simply in the cleanup phase. So we can report back to the folks who need to know, hey, we're in the cleanup phase. The ramp's partially open. We're good to go. Next slide. For those of you who use PDA, congestion scans, dash cams actually show up, and you have the ability to search for dash cams in your congestion scan. So what you're seeing there on the right is, it's a congestion scan. You see the slower speeds behind the incident, and those lines coming up are the actual trucks with those dash cams coming up the road. And each dot is sort of an image capture, right, from that dash camera. And so, again, an area that we have no cameras. We don't know what happened. We can actually go back in time and see what is happening at this scene, what was involved, right? So here's kind of a verification of what how significant this incident was. So this was a tractor trailer crash that was it took a while to clean up. Next slide. This was in Northwest Mississippi back in late January with that big event. Again, another congestion scan. You kind of see the string of dash cams coming up the road. The reason they're kind of slanted is it's folks are traveling pretty slowly. Time is moving left to right. But you kind of see, early in the day, what conditions were like for those truckers that were driving up the interstate. And then later in the afternoon and towards the evening, conditions haven't changed much. That solar radiation really didn't do anything to help melt anything on the roadways. So again, you can kind of go back in time and look at conditions. All right, next slide. This is my last one. This was a snow event north of Pittsburgh, I-79, I think. They had a snow squall, shut down the highway. Pretty bad incident. That's that picture in the middle. We saw a drone video, pretty unique view. And so our thought was, hey, can we go back in time and see what were conditions up to the event, and maybe just as things are clearing. And that gray area in the middle is when they've actually shut the highway down. But you can see you can actually add in, the weather layer with your congestion scan and see when the heavy snow was starting to come in. You can start to see it picking up on the dash cams. And then towards the end, as traffic gets moving again, this is one of the first trucks being let go and coming through the scene, up to the scene. So you can see him sort of trailing the plow truck as he's headed up or headed down the road. So yeah, pretty promising information, visuals. So we've actually incorporated this into our sort of workflow to, actually go out and look for these pieces of information. Next slide, and I think that's it. Back to you, Michael. Or Jesse.
Thank you. Great stuff. Really interesting application. Moving into our next spotlight presentation, we have William Morgan to talk about RITIS data for ramp metering. So take it away, William.
Thank you. Let me share the PowerPoint. Hello, everyone. I'm William Morgan. Thank you for that introduction earlier. Today, I'm going to talk about ramp meters in Georgia and how we also use RITIS to evaluate the performance to timing changes made to the ramp meters. So first, I will go over a brief overview of ramp metering in Georgia. So in total, we have 235 ramp meters. They're mostly in Metro Atlanta. On the map to the right, every yellow dot is a ramp meter. We currently have a few in Columbus, and we have a few coming up in Savannah. They mostly consist of single or double lane meters, though we do have a few 3-lane meters and one prominent 4-lane meter to the northbound connector from Freedom Parkway in downtown Atlanta. We have no freeway to freeway meters. There's an asterisk there because we have one location that's out there in the field, but it's just sitting in dark right now. And we have mostly avoided installing meters on collector distributor ramps, though we do have a few where the ramp volumes are not very high. And we have one unique metered entrance to the reversible toll lanes near the Cumberland area, if you know Metro Atlanta. Next, I'll go over the components for our ramp meter systems. We use Caltrans 334 spec cabinets for our signals for the single lane meters. Those are typically just sitting on a pole, and then there will be a signal head on top for people further back on the ramp, and then a lower signal head pointing directly at the stop bar so that people waiting for a green know when they get one. And then for the multi-lane ramps, we tend to use a mast arm, though we do have some pole locations out there for double lane ramps still. All of our meters have advanced warning signs. Those are just diamonds that say ramp metered when flashing, and then there's a beacon on top that will flash when the meter is active. Then there's mainline detection. That's what conveys the flow state of the freeway to the cabinet. We currently use mostly video detection, and they mostly run off of average speeds, though we do have some locations where we've kind of refined the occupancy thresholds to let the cabinet use that too. Then there's the detection on the ramp. There's passage, demand, and queue detection. The passage detection doesn't really do too much the way we currently run things. Technically, if a car hits the passage detector and it's showing a green, that'll end the green, but we also have a 2-second max out on the greens, so that tends to end most greens. The demand detector, though, when the meter is active, it will stay red until a car hits that demand detector. Then we have queue. Almost all locations have excessive queue, and some have intermediate queue. The way the excessive queue works is it's a loop sitting in the back of the ramp. If it senses that cars are moving slowly over it, it will begin to increase the meter rate, which is letting more cars onto the freeway. That is to prevent spillbacks. And outside of the downtown connector, if it senses very high occupancies for over a minute, it will perform what we call a flush, where it just turns off the meter for a minute before starting back up again. The intermediate queue is about halfway between the excessive queue and the demand detector, and it's there to more gradually bump up meter rates when it senses cars are on top of it. And it's to, I guess, it allows us, if it's not active, then we know that the ramp is not anywhere near full, and it allows us to run lower meter rates. Then for signage, there's kind of 2 signs that are unique to the ramp meters. There's the stop here on red and the 1 car per green, and those are just to tell drivers how to use our ramp meters. I'll briefly go over what ramp meter software we use. It's Q-Free Max Time Max View. There's a screenshot of it there. I'm not too familiar with what else is out there, so can't really speak to how I feel about it, but it works. Then we have just the operations philosophy in general. Our goal is to reduce overall congestion. This is accomplished by increasing throughput on the freeway, but we try to make sure that we don't cause gridlock on the signalized roads. The meters are run in a local traffic responsive manner, so metering rates are set by time of day along with speeds and occupancy of the freeway. So it's basically for each meter plan, it is a table with a set of rates depending on speeds, and that table will change by time of day. We evaluate performance ideally using count data, since throughput is our performance measure. The screenshot on the right here is one of our Office of Traffic Data's count stations. This is the one on the downtown connector. A lot of segments won't have a count station, and sometimes our count stations go down due to construction. And so in that case, we will use probe data and kind of use speeds to try to proxy throughput. Now I will kind of go over the idea behind how ramp metering works for those who are unfamiliar. So why do we meter? It's to mitigate automotive traffic congestion by maximizing flow on freeways. And so the main causes of freeway congestion are incidents, accidents, queues of exiting vehicles which spill backwards onto the freeway, bottlenecks, and flow disrupted by platooned entering vehicles, which create shock waves. Ramp meters can mitigate the latter 2 causes. and it's by reducing the volume of entering vehicles at bottlenecks, which is where demand for the downstream segment exceeds the service rate provided by that segment. It'll allow the cars on the freeway behind it to be better able to use that segment. Then by chopping up platoons, space is created between vehicles to smooth the merging process, which will lower the density of vehicles at the merge point. And by doing that, that has been shown to delay bottleneck formation. It increases throughput when the bottleneck is active, and it speeds up the recovery of flow after peak periods. But if you are setting meter rates, it's always important to keep in mind that there is such a thing as too low of a metering rate, and that's because you may starve the bottleneck where the downstream segment is not pushing through as many vehicles as possible. Or you may redirect trips to enter the freeway at less desirable locations, which will cause larger negative impacts on total throughput. So do we have any proof that metering works? Yes, I think this is my most prominent example. It was the downtown connector northbound. Back in July 2024, the Spring, Linden, Ivan Allen Williams ramp meter, which it's leaving the central business district, it was disabled. In August 2024, I enabled it. And in April 2025, the improvements were kind of still there. In August 2024, the improvements were very large. The notable exception to the sustained improvements was during the PM peak, and later on during the presentation, I think I've reduced the drop, but I don't have the counts to be sure of it. So to put numbers to the improvement, the August was 6.5% better overall, and in April 2025 it was 5.4% better, and during the peak hour, which is 7 a.m., it was 11.2% better in August and 10% better in April. So now, kind of going off of that, I'll talk about how the location of the ramp really kind of affects what it's doing a lot relative to the bottleneck. So on this map, this is the northbound connector. In light blue is that Spring ramp meter, and so it is after the bottleneck point. And so what it's really doing is it's just the mainline detector is just there to detect shockwave formation. And once it does, the meter will pop on really quick, kind of chop up the platoons, make it easier for people to get off at the next exit, just smooth out that merging process. And then the speeds will recover, and then the meter turns back off. And it's just to keep that segment behind it essentially green on the traffic map. Then there's the dark blue meter. That's Freedom Parkway northbound. That is at the bottleneck. That one is trying to reduce entries and essentially keep the highway behind it moving as much as possible without causing too much impacts to the ramp. Then there's the 4 in orange, which are Dobbs, MLK, Fulton, and University. Those are really just kind of responding to the length of that queue behind Freedom. And so once the queue reaches there, the meter turns on and it begins metering pretty hard. And I will go into the implementation of that. So restrictive ramp metering is when the metering rate is set below the non-metered ramp volume. I guess my advice for implementing that is it should only be done post-breakdown of mainline flow. It is done to shift freeway arrivals to more desirable from a system perspective access points. And to properly pull this off, adequate ramp storage must be provided. Guidance out there says it needs to be more than 5 to 10% of peak hour volume. And I guess to kind of wrap up this section, I will go through some common arguments against ramp metering and why I kind of disagree with them. The first one that you hear the most is traffic diversion, which is that essentially all the ramp meter are doing is it's shifting congestion from the freeway to adjacent arterials. But if it's implemented properly, metering should only be implemented on corridors where traffic diversion is already happening due to the severity of congestion. So as long as when you consider lower meter rates, the increase in throughput on the freeway is greater than the decrease in throughput on the ramp, it will cause a net decrease in diverted trips. And so actually the meters should be causing less traffic diversion on net. Then there's the equity argument, which kind of states like wealthy suburbanites are being prioritized over poor city dwellers. I don't think the ramp meters are promoting longer trips because by restoring capacity lost due to congestion on the freeway, due to equilibrium effects, travel times on adjacent arterials should improve as travel times on the freeway improve. And I think with the most recent adjustments to that northbound connector, I have seen this happen. And I'll go over that in the next section. Then there's the socioeconomic argument, which is essentially the observation that areas around freeways tend to be poor, especially at the back of a bottleneck. But ramp meters don't shift traffic congestion and associated impacts from one location to another, as I had gone over earlier. Our goal is to shorten the queue behind the bottleneck while keeping impact confined to the ramp segment. And I think you'll see in the next segment that I think we've had success doing that. And so while, yes, the areas around the back of the bottleneck of the freeway tend to be poor, and we tend to put ramp meters there because of the congestion, I don't think the ramp meter is causing the area to be worse. So now I'll go over how we sometimes use RITIS to evaluate ramp meters and the evaluation of the most recent changes I have made to the northbound connector. So some background on this area. The continuous count station on the downtown connector that I showed earlier went down in July 2025 due to repaving. After observing ramp meter operations along that corridor, I decided to try implementing restrictive ramp metering at 3 locations at the end of September 2025. Those locations are Freedom Parkway, which is at the bottleneck, then Fulton Street and University Avenue, which are behind the bottleneck. And why did I do this? Like, what were the observations? So not only did I note that there was spare storage on the ramp, also when looking at the merge point, I saw pretty often that it was congested. Essentially, like there were vehicles trying to merge onto the freeway that couldn't find a gap. So to analyze the improvement, I used RITIS Probe data analytics temporal comparison maps. I prefer year-over-year comparisons to filter out seasonal effects. So in this case, that would be October 2024 every weekday versus October 2025 every weekday. The time range I chose was 6 a.m. to 10 p.m., which is when the ramp meters are active or available. To determine the spatial scope of this analysis, I started with the corridor in question, which is the northbound connector. I selected all of the ramps along that corridor using the map tool. Then I checked connecting freeways and continued upstream until the improvement disappeared. So that included I-20, which led to I-285 also being included on the west side of Atlanta. And it also included I-75, I-85, and Georgia 166 before the Lakewood interchange. Essentially, I was just searching for reduction in rear of queue, presumably due to increased throughput. I did kind of feel that this is a bit cherry picking the data, so I also offered a result that was just with the northbound connector. So now it's time to assemble and calculate the reduction in delay. So for each segment, the average speed from each time period was entered into an Excel spreadsheet. Then I measured the length of each segment in Google Maps. Then I entered the AADT for each segment from GDOT's traffic analysis and data application. And then using that information, the change in vehicle hours of delay per day was calculated using the below formula. I think most of that formula is written in plain English except for F. And so F is just a factor that I used to convert AADT to approximate 6 a.m. to 10 p.m. counts. Here's a screenshot of the Excel spreadsheet. So there's kind of clusters of columns here. The left cluster of columns is the connector highway itself. And so you can see on the deltas, it's mostly positive numbers. And then the second cluster of columns is the delta of the ramps. And so you can see that the Freedom ramp, it had a significant drop in speed, about 10 miles per hour. The Bolton ramp dropped 6 miles per hour, and the University ramp dropped 3 miles per hour. I also included freeway to freeway ramps here. And then finally, for this third cluster of columns, these are those, I guess I call them tails of the bottleneck, those adjacent freeways that feed into the connector. And so I guess the result was that the reduction in delay on the northbound connector from October 2024 to October 2025 was 3380.6 vehicle hours per weekday. If you include adjacent freeways, the reduction in delay could have been as much as 6238.1 vehicle hours per weekday. So the conclusion is that the reduction in delay on the freeway and freeway to freeway ramps outweighed the increase in delay on the metered ramps in terms of vehicle hours. And this was calculated without even considering that volumes on the metered ramps probably decreased after dropping those meter rates, which would make the delay reduction numbers look even better potentially. However, there are a lot of simplifications in this analysis, so at least these are the ones that I thought of. During rush hours, the Q spillback is known to go onto the adjacent arterials, but I did not query their changes in speeds for this analysis, and so that may make the numbers look worse. And the reason that they spill back onto the arterials is because on the connector, we don't flush those ramps. I am also assuming that the effects of crashes is mitigated by doing month-long analysis periods, but it is possible that the crash rate in October of 25 was less than the crash rate of October of 24. Also, I'm assuming that both analysis periods did not see major disruptions from construction activities, which I cannot be 100% sure of. Then also behind the segments where the Q on the freeway was reduced, RITIS shows a drop in speed. I'm assuming that that drop in speed was not caused by changes made to the ramp meters, and so I excluded that from the analysis, which that choice makes the numbers look better. And finally, I am also assuming that both analysis periods saw similar disruptions due to weather, because in Atlanta, any sort of precipitation does have a pretty large impact on traffic. Finally, I will show Google Maps typical traffic corroborates these results. So these screenshots are the typical Wednesday at 8 a.m. And so I will first start by pointing out the connector itself. So we can see that this earlier screenshot, which was before the rates were turned down, behind Interstate 20, that's all red. And then now you can see that there are patches of yellow along that segment. And then if we look at the Lakewood interchange, you can see the ramp for reroutes is actually experiences some congestion, and now that is gone. And then also if we look on adjacent corridors, you can see improvements too, like US 29, which is a common reroute. It showed red in the morning earlier. Now it's just yellow. And then US 23, that was red. Now it's yellow. And then finally, Interstate 285. On the west side of town, it was yellow. Now just green. That is probably, to me, the most surprising result. And then on the east side of town, around Georgia 10, north of it, it's red and now yellow. I think the only thing from this map to me that looks kind of potentially bad news is that I-20 feeding into the connector, that the queue does seem to have increased, but maybe that's just because that segment north of I-20 is more desirable to use now. Then I'll go over the PM map. I wish I had taken a screenshot before I made the changes, but I did not. So you're just going to have to kind of trust me on the conditions beforehand for this one. And I only was really paying attention to the connector itself. But the queue in the PM, it used to be solid red behind I-20 all the way until the Lakewood interchange here. And kind of like in the morning, you'd see that diversion ramp would see congestion. Now that diversion ramp is green. The queue is halfway to University, and there's patches of yellow all the way up until University and between University and I-20, which is really, I guess, much better than I had expected before I had made those changes. So in conclusion, lowering meter rates when the merge point is congested, and especially if there's also spare storage on the ramp, resulted in freeway queue reduction and overall delay reduction. The suggested throughput was increased, which is our primary goal. Thank you for your time. Feel free to ask any questions.
Thanks, William. That was really great. Folks have questions, just a reminder. And we have one more presentation, right?
Okay.
Okay.
Yes, we do.
While the screen is loading up, I believe Ian Newman will be our next presenter. And we're just seeing it loading, and there it is now.
Excellent. Thank you, Jesse. Good afternoon, everyone. My name is Ian Newman. I am the program manager for travel monitoring and planning assistance over at the National Capital Region Transportation Planning Board. We are the NPO of the Washington, D.C. region. And so my presentation today is going to be focused on the congestion management process and specifically TPB's congestion management process technical report for fiscal year 2026. A bit of background before I get into a very brief dry run through the technical report. The technical report is a biennial product that in the past was limited to a PDF, and oftentimes that PDF exceeded 250 pages. Data was static, and the language could be a bit difficult to understand unless you had quite a bit of experience and knowledge in this space in the transportation world. And so the TPB decided to change the structure and the format of our CMP and all of its products, including the technical report, to something that values data interactivity, accessibility, greater understandability, user ease, and innovation. This is a living document, and so data will continuously be updated in this document, and so we do not have to wait an additional 2 years, nor do our stakeholders and partners have to wait an additional 2 years before the next round of data becomes available to be showcased across the congestion metrics that we're focusing on. And it is kept to a high to medium level in order to reduce wordage and to promote greater understandability. And that wordage is designed for a reader who is starting their first day of undergraduate in planning or civil engineering or a related field to the most senior officials at the FHWA or the FTA, and really everyone in between. We wanted to make sure that this document is understandable and not condescending to anyone. And so without further ado, I am going to take you through a brief overview of this presentation. I'm just going to set my timer real quick here to just keep us on time. Okay. So the story map, ArcGIS story map, to be specific, it's divided into 16 different chapters. We have the chapters listed up here as tabs. I'm not going to focus too much on these introductory chapters. Really, they're just to set the stage for the report as a whole. And so we have our executive summary with key findings that were derived from the data, our key acronyms. And so essentially putting the glossary first. the performance measures that are being used, and not just their definition of that performance measure, but also what is that metric used for? How do you interpret that metric in more easy to understand everyday language? What is the equation of that metric? And then the source of the metrics data. And as we're at the RITIS user group meeting, the vast majority of the data came from RITIS across the NPM RDS analytics suite and across the PDA suite. Just going through this a little bit faster here, just so that I can get into the data portion of this presentation. We do also have a nice slide car with all pictures found throughout this report from the TPB region. Okay. The introductory section really just discusses travel demand in the region. And so we're looking at population share and jobs share across our region. Interactivity is a consistent theme found throughout this story map, and so a user is able to click anywhere and understand, percent of population share in this example, and the estimated population for each jurisdiction. Please keep a note that this is also a rough draft document, and this is going to be submitted to the FHWA and FTA in June of this year. This is the first time showing this document externally, actually, and so I just want to reiterate that it's a privilege to be with you all today and to be showing you this. Right. Yep. Same idea for jobs. We're here, and so a user can, or zoom in and play around with this interactive map. The introduction really covers, what is a congestion management process? What is the objective of the CMP technical report? Why is congestion even an issue in the TPB region? And so getting into issues concerning economic development, issues concerning safety, issues concerning lost time and lost productivity and environment. And so essentially, why is congestion an issue? And then real quick, just going into a federal regulations chapter that discusses how the TPB is compliant with FHWA code and how our CMP meets the 8 stipulations that are set out. One thing that is a consistent theme of this document are these please click here's, these hyperlinks to more detailed reports, more detailed PDF summaries that really help go and take a concept and go into the more granular element of that in order to keep this document high to medium level and to reduce wordage. Often throughout the document, we find these please click here for more information. And so we have a paragraph and some bullet points that explain how we are compliant with code, but we also have an 8-page PDF document that if a user is interested in that space, clicking on and directed to a PDF. Now for the main piece of this presentation for our group here today, we looked at 10 different metrics across congestion. They're separated out into reliability, congestion intensity, system usage, and then causes of congestion. With reliability, that's our largest group of metrics. And so we have 5 different metrics that comprise our reliability metrics. We're looking at planning time index, travel time index, and buffer index, in which we gather the data from RITIS, probe data analytics, performance summary tools. And then for the level of travel time reliability and truck travel time reliability, TPB staff utilized the dashboard tool from the NPM RDS analytics suite. So each section starts off with essentially discussing what question is trying to be answered or trying to be solved by these metrics. And so, for example, with reliability metrics, how predictable and reliable are traffic conditions across the roadway network for trip making? Am I going to make my trip on time? Is essentially what we're trying to help answer. We have our parameters that are set up here for the data to be collected from RITIS. And then we have these Power BI interactive dashboards that utilize this RITIS data. They're all interactive, and you can hover over and see, for example, truck travel time reliability, how this number has been changing over the years. We also include for many of these metrics slicers to divide the data. And so, for example, across all highways, which is looking at interstates, US routes, state routes, parkways, turnpikes, and expressways from the RITIS functional classifications, a user is able to toggle this, say they would like weekdays, and say they would like an AM peak. You can see how this data adjusts accordingly. Of course, this can be expanded out into a greater picture in a new tab. And then we also have an about this section, which helps explain details and how to read this chart a little bit more clearly. And so, for example, for travel time index, lower values indicate less congested conditions. However, for level of travel time reliability, this graph shows the share of person miles traveled under reliable conditions. And so higher values reflect improved travel time reliability. So we have this for LOTTR, TTTR, PTI, TTI, and buffer index. And we're looking at 2016 through 2025. All major highways or all highways and interstates only. And our AM peak and PM peak, AM peak is 6 a.m. to 10 a.m. and PM peak we have 3 p.m. to 7 p.m. Unless it is level of travel time reliability, in which that is set for 4 to 8 p.m. for that PM peak. Here we have another in-depth discussion about what that metric is and what that metric is utilized for, the equation, interpretation of sample results from that metric. This gets into a discussion about why we use that 4 to 8 p.m. For LOTTR. And then key discussion takeaways from each metric. And this is found throughout every metric in this report and its corresponding roadway groupings. So for example, with level of travel time reliability, we're looking at the national highway system excluding interstates. What are 5 key discussion points, key data takeaways from here? Likewise on interstates only. And then same thing with truck travel time reliability. Again, what is it? What is it used for? How, in this case, how is it different than level of travel time reliability? Its equation. How do you interpret sample results? And what do those sample results mean in more layman's terms? And major findings. Same thing with planning time index. I'm just going to go a little bit faster here. Travel time index and buffer index. With, of course, our major findings for each one. Those major findings help drive the executive summary in terms of what are some really key takeaways to share with not only external stakeholders that are quite involved and quite interested in the data analytics side of transportation planning and transportation engineering, but also our policy members and elected officials in the region. Then we get into congestion intensity metrics, and these congestion intensity metrics help answer the question, when congestion occurs, how severe are its impacts on travelers and the regional transportation system? We're looking at peak hours of excessive delay and vehicle hours of delay. For this one, we used, similar to the reliability metrics, both suites of tools. For the vehicle hours of delay, we utilize the user delay cost analysis tool in the probe data analytics suite. And for the peak hours of excessive delay, the PM3 reports, which was mentioned earlier in this meeting. Our parameters that we have set here, and then we have our next dashboard. This one we are showcasing. I'll expand this in a new tab just so people can see it a little bit more clearly. So here we have our peak hours of excessive delay aggregated. Again, everything is interactive and everything is able to be downloaded straight from the dashboard in terms of the data. Our PHED per capita. And then we also have our median PHED facility. And so taking a look at that TMC segment from the national highway system and basically saying 50% of TMC segments are experiencing worse PHED, or in other words, higher levels of vehicle hours of excessive delay during the peaks, and 50% of those segments are experiencing less hours of excessive delay on those segments. And so it's another metric, or another sub-metric rather, to help understand this greater peak hours of excessive delay a little bit more on the granular scale. We're also comparing the Transportation Planning Board across other metropolitan planning areas. And so we have the TPB lined up against 14 other very large MPOs and their MPAs. And so, except for Richmond, Virginia, our TPO, we included that one just to, it's a regionally significant MPO, as Richmond is only about a couple hours away from DC. But you can see here on this chart where we're looking at 2024 peak hours of excessive delay and the metropolitan planning area's population, Richmond is quite an outlier and only at 2.59 PHED per capita. This purple one here is our Transportation Planning Board region. That's 15.28 PHED per capita. And we have a couple of outliers over here to the right, such as NIMTIC, so the New York MPO, New York City MPO, and SCAG, so Los Angeles. Taking a look at vehicle hours of delay, similarly to the other metrics that you've seen so far and the ones that you'll see here over the course of the next 10 minutes, we have our vehicle hours of delay across that congestion management network that we're calling all highways. So that's our interstates, US routes, state routes, parkways, turnpikes, and expressways aggregated, and then taking a look at that as interstates only. And then our vehicle hours of delay per capita as well, from this one from 2017 through 2024 for the per capita. And a quick about this visualization as well. And the user can also play around with these dashboards from within the story map as well. I just like to expand it and put it in a new tab. Again, we have discussion on the major findings of PHED. And then same thing with vehicle hours of delay. Then we get into our system usage metrics. And so for system usage, we're taking a look at metrics that help answer the question of how much travel is occurring on the network and how extensively does congestion affect roadway facilities across our region. We're taking a look at VMT and VMT per capita, and then percent of congested miles. For this one, we are taking a look at the user delay cost analysis tool, again, from the Probe Data Analytics Suite for our VMT. And then we use the massive data downloader from NPM RDS Analytics for the percent of congested miles. And here we have it over here. So again, the user can hover over and take a look at VMT by year for interstates and all highways, as well as the per capitas and our percent of congested miles. With discussion. And then finally, we get into our causes of congestion, 2 chapters. So here we're taking a look at the RITIS causes of congestion graphs tool that was found in the Probe Data Analytics Suite. This is the only section that is using only INRIX data. The other sections were using NPM RDS data. But NPM RDS data was quite nicely abundant throughout these metrics, and so we really appreciated the consistency of being able to use that data set across the metrics that I've shared with you previously. So here we have another visualization. I'll expand this in a new tab. Another way of how to read this visualization. So it's just a reminder about our AM and PM peak hours. As we have a slicer down here, so I can say, hey, in 2020, let's take a look at what the causes of congestion look like. And this is causes of congestion as it relates to the vehicle hours of delay. And so, for example, on all highways, weekdays, during the PM peak, I'm taking a look at how this percentage is the percentage of congestion that is attributed to that cause. Multiple causes being really the significant lion's share one across most years and most day and time periods that we've incorporated. But it's also important to see how recurrent congestion on its own, for this example, accounts for over 32% of congestion as and that's just recurrent congestion without it being paired with any other cause of congestion. And same thing with signals. Of course, this goes away if I switch to interstates, and a user can toggle for a different year, different time period, different roadway classification. Let's go to our all times so that we can take a look at all days, all times, 2024. I'm gonna head out of this and I'm gonna go ahead and just kind of wrap up here. Each cause of congestion has its own chapter dedicated to it. And so I'm going to get through this a little bit faster. And as part of the CMP, we identified 10 unique strategies that the TPB sponsors or endorses or puts on within our region to combat, for this case, non-recurring congestion. And that's part of a series we're calling our Congestion One-Pager series. Name still in progress.
Ian, I'm sorry to cut you off, but it looks like we're out of time here. We're seeing some folks dropping off the webinar. Hopefully folks could reach out and follow up with Ian because I think this is something that a lot of people will be interested in. Really great, interesting visualizations. Sorry to cut you off there.
All good. That's totally fine. No problem.
Hopefully you were close there, but again, I think Ian shared his contact information. Folks could reach out with any other questions. Again, I think it's something a lot of folks are working on in terms of how to, share the complexity of the CMP. And there was one question in the chat that maybe we can follow up with offline, just kind of asking about, how are you framing some of the different metrics? Is there like one particular metric or are there different ones for different situations? But I think we'll have to follow up offline. Nicole, if you want to bring up the poll, we do have just a closeout poll for folks. Thanks to the folks who've hung on. I know in the world of Zoom meetings, we all probably have meetings to go to next. So again, sorry to cut you off there, Ian. And I think most of the questions in the Q&A have been answered. So hopefully we're not leaving anybody hanging, but if you do have questions, feel free to send them to the team. And if you have time to just quickly answer these last poll questions, I was just looking for, topics that folks would be interested in for future meetings, or any feedback that you have on specific tools, how they're working, if they're not working for you, stuff like that, so that the team can address them. So we'll give a few moments for that. Thanks again to all the speakers. A lot of really great presentations today, really different applications, which is always really interesting to see all the different ways that people are using the tools. So as always, just appreciate people's time and participation today. And thanks for staying with us a few extra minutes for those who hung on.
Thanks, Jesse. And it looks like we might have one hand raised and see if maybe Atit has a question. Okay, maybe not. Thank you very much, Jesse and Michael and William and Ian and Taryn, for the great presentations. And the poll questions are still up if you'd like to answer. And with that, we will be meeting again in June. So be on the lookout in the next month or so for that invite. And again, you can always reach out to me if you have any questions. If you'd like to get in touch with RITIS, we do have this support@ritis.org email address that you can use to contact us for that. So again, thank you and have a good rest of your day.
Thank you. Appreciate it.
You're welcome.